Hey class, so back by popular demand are these homework help videos. I've had a request from a few people to discuss problem number 3 on the workshop, so I wanted to talk to you a little bit. What we have here is an object that's oscillating on a spring back and forth, and we're asked to determine the amount of time that elapses between the instant that the object is at its maximum speed, which is 1.5 meters per second. So I'll go ahead and label that Vmax equals 1.5 meters per second, and the moment that the acceleration is at its maximum, which is 6.5 meters per second squared. Okay, so interesting to know. We can think and we recall that the maximum velocity occurs at equilibrium. The maximum acceleration is going to occur at amplitude. And so that's good to keep in mind. But first thing, well, actually, going along with that, keeping that in mind, that's if we think about our object, if this is negative amplitude, here's our equilibrium point, and up here is our amplitude, right? What we're saying is that, all right, if an object is moving this direction, right, it'll come here and then eventually it'll return. We're looking for the time that it takes just to travel from equilibrium to the point of maximum acceleration. So if we think about our period, for example, which we might be able to learn more about, we're looking for a time that's equal to 1/4 of our period. So if we find the period divided by 4, that's going to be quite helpful. Alright, so I'm going to circle that for later. It's not box worthy, but we can circle it. So the question then is, how can we determine what the period is? Well, we know that there's a relationship between period and frequency, or angular frequency. For example, we know that period is equal to 2 pi divided by the angular frequency. So if we could find angular frequency, that would enable us to get our period. Cool. So that's all good and helpful. How do we go about finding our angular frequency? Well, we know there's a relationship with our maximum velocity. We know our max velocity is equal to omega times a. We talked about that in class a couple times. And we also know that our maximum acceleration is equal to omega squared times a. Now, we don't know omega or a, but now in this case, we would have two equations with the same two unknowns, omega and a. So as you can see, given the fact that we have our max velocity and our max acceleration, we can plug these in here, two equations with two unknowns. You should be able to determine a value for omega and a value for a if you wanted. And then once you have omega, you should be able to investigate what the period is, which then allows you to figure out the time you're looking for. So I'm not going to solve this all the way. I'm going to leave it there and let you guys go ahead and try to get the correct answer. Hope you guys have a great weekend and look forward to seeing you all on Monday.